students. In last video we have learned how to find out eigenvalue and eigenvector for the square matrix. Now we are going to study the concept of diagonalization. Now first let us understand what is the procedure. Now in this video we will be dealing with 2 cross 2 matrix, and in the next video we will pick up 3 cross 3 matrix. Okay. Now the very first step you have to do is find characteristic equation. Okay, now how to find out characteristic equation? Determinant of a minus lambda I is equal to 0 gives me the characteristic equation. But I have told you a shortcut that you can directly use lambda square minus p1 lambda plus p2 is equal to 0, where p1 is equal to trace, that is the sum of diagonal elements, and p2 is determinant of a. So when you see this you feel that it is lengthy, but no, when you use this formula it works like anything. It's very easy and very simple. Now second step, once you get the characteristic equation, find characteristic roots. Okay, that is the roots of this equation, which gives you eigenvalues. So that will become your eigenvalues lambda 1 and lambda 2, right? Then third step, find eigenvector x1 and x2 for lambda 1 and lambda 2. Then fourth step, you will form the modal matrix. The modal matrix P is given by x1 and x2. Both the eigenvectors I will write like this, which will give me the modal matrix. Step 5, we will find P inverse. Step 6, we will find D is equal to P inverse AP. So the moment you will do P inverse AP, you will get a diagonal matrix. Okay, if you get diagonal matrix means it is diagonalizable. And you have to remember the diagonal matrix will always have the structure lambda 1, 0, 0, lambda 2. The place of lambda 1 and lambda 2 can be exchanged if while calculating you have exchanged the things. So there is nothing wrong in that. That's perfectly okay. Step 7. We can raise a matrix to certain power, and that is obtained as a to the power n is equal to p d to the power n p inverse. So when we know that D is a diagonal matrix, raising it to a power is not a problem, because only diagonal element you have to raise to that particular power. Then you have to multiply it like this and you will get the answer. I may suggest all of you to avoid you doing manually P inverse or the multiplication of the matrix. Use calculator wisely. If you don't know how to use the calculator, see my videos where I have taught you how to use the calculator. So these will be the steps in this concept. So now let us start with the question. Now the very first question is, find a modal matrix. Modal matrix means P, and diagonalize this matrix and also find a to the power 4. So everything you have to do in this question. Okay. So now let us start with the first thing. So first thing, I need the characteristic equation. So as I said, characteristic equation is given by lambda square minus p1 lambda plus p2 is equal to 0. Now what is p1? P1, as I said, it is trace. Trace means sum of diagonal elements. So 4 minus 1 is how much? 4 plus of minus 1 means 3. Okay. And what is P2? P2 is nothing but determinant of this A. So what is the determinant here? It is minus 4 minus plus 3 to the 6, that is 2. So what is my eigen characteristic equation now? Lambda square minus 3 lambda plus 2 is equal to 0, right? So this is my eigen characteristic equation. Now the roots of this characteristic equation give me the characteristic roots, which are also known as eigen values, correct? So now I will find out the root of this. So let me find out the root. You all know splitting the middle term. So you can write 2 factors of 2 whose sum is 3. So lambda square minus 2 lambda minus lambda plus 2 is equal to 0, and this will give me lambda minus 1 lambda minus 2 is equal to 0. Okay, implies lambda is equal to 1 and 2. So this is the set of my eigen values. Again, I will suggest you कि instead of doing this, use calculator so that you will get the practice. Now, corresponding to each eigenvalue, I will find out eigenvector. So, how to find out eigenvector? We know that if we write in a matrix form, A minus lambda I x is equal to 0. Correct? So, the same thing I will be writing now. Now, in this case, what I will be writing, what is my A? A is this given matrix. When I am saying A minus lambda I, means diagonal elements I should subtract by lambda. So, minus 1 minus lambda, 3 minus 2, 4 minus lambda. Just look at this matrix. Only diagonal elements I am subtracting lambda there. Here capital X is a simple one vector is equal to 0, 0. Now, this is my standard equation I will be using for eigenvector. So now for lambda is equal to 1 when I am doing, in place of lambda I will put 1. So what I will get here? Minus 1 will become minus 2, 3 minus 2, 4 minus 1 is 3. So this gives me xy is equal to 0, 0. Implies minus 2x plus 3y is equal to 0. 2x is equal to 3y. Now, what you should do? You should divide by the LCM of these two numbers both the side. Actually, I just want the coefficient in the numerator to be 1. So, the best idea is divided by LCM. So, LCM of 2 and 3 is what? 6. So, divide both the side by 6. So, this will become x by 3 and this will become y by 2. So, what is the eigenvector? The first eigenvector is 3, 2. Correct? Now, let's work for the second eigenvector. So, lambda is equal to 2 I will do. So, now in this equation, in place of lambda, I will put 2. So, what you will get? Minus 1 minus 2 is minus 3, 3. Minus 2 and 4 minus 2 is again 2. So, xy is equal to 0, 0. If you observe, always I am getting the same equation. So, same equation means first row is giving me one equation, second row is giving me second equation, but both the equations are coming same. Okay. This will not happen same way in the 3 cross 3 matrix. It will be different. Okay. So, minus 3x plus 3y is equal to 0. See, minus 3x plus 3y is equal to 0. So, we are multiplying this by this, then plus this by this. Okay. So, 3x is equal to 3y. Now, if I divide both the side by 3, what I'll get? X by 1 is equal to y by 1. So, what is the eigenvector? Second eigenvector is 1, 1. So, now what is my modal matrix? Modal matrix P is equal to, what is the first eigenvector? 3, 2, 1, 1. Correct? So, now I got my modal matrix. Now, what is my next work? I need to find out inverse of this modal matrix. So, all of you use the calculator. I know 2 cross 2 you can do orally also, or you can do by process also. It won't take much time. But then also I want you guys to practice calculator. Those who don't know how to use it. So, I am using FX991ES. So, accordingly I will tell. For other thing you can see other model, if you have, you can see the video. I have uploaded the videos of different models. Okay. So, now in this model, how I am going to do? First I will go to mode. Then I will go to matrix. Then I will pick up one matrix, mat A. Since it is a 2 cross 2 matrix. So, I will press 5. I will get down this. Now, I will put the values 3 is equal to 1 is equal to 2 is equal to 1. So, now I have put the values. So, on shift 4 when I do, they are giving me the option. Since I named it mat A, I will press 3. Now, I want inverse. So, I will put just inverse of this and I got my answer, right? So, what is the value of P inverse? P inverse is equal to 1, minus 1, 2 and 3, right? So, 1, minus 1, 2 and 3 I got as my inverse. So, this is minus 2, not 2, minus 2, okay? So, I got the P inverse, okay? Now, What is the next step? I need to check whether it is diagonalizable or not. So D is equal to P inverse AP. Correct? So you write down P inverse, that is 1 minus 2 minus 1 3. Remember, when you handle matrix, A into B is not equal to B into A. So order matters a lot. Right? A means your question. So what was your question? Go back to the question. Minus 1 minus 2 3 4. So minus 1 minus 2 3 4. Okay. And then P inverse AP. What is P? P is 3 2 1 1. Now again you can go back to calculator. You can pause the video here, multiply these three and check what you are getting. So see what I am getting. I am getting 1002. See, always your eigenvalues will come in your diagonal. So in exam, if you are very sure that your P and P inverse are correct, you can write directly also. But in calculator, if it will take hardly 1 minute to check, because if in case it is not coming, means you have done some mistake. So you can catch your mistake at this point. So now I got D. Now what exactly I want to find out? What is the power of A? I am searching for A to the power 4. If I am looking for A to the power 4, means I need D to the power 4 also. Right? So D to the power 4 is equal to 1 to the power 4, 0, 0, 2 to the power 4. Right? So this will be equal to 1, 0, 0, 2 to the power 4 means 2 to the 4, 4 to the 8 to the 16. Correct? Now A to the power 4 is equal to P D to the power 4 and P inverse. Means what is your P now? P is 3 2 1 1 1 0 0 16 and P inverse is your 1 minus 1 minus 2 3. So now if you remember how you have saved your matrix, then it's fine. If you don't remember, then you redefine the matrix and then you multiply it. Okay, so now we will multiply these three matrix. So pause your video and then check the product. So I got this answer when I have multiplied 3 matrix. Okay, now here if you want to cross check whether you have done it correctly or not, what you can do, go to mode, fix a matrix A, which is your question, and then multiply it 4 times. That will also give you the same answer. So if you are scared of multiplying 3 matrix, you can always check like that. Rather checking, you just write down the formula and you can write the value also. Okay, so now let's come to the next question. Now you have to find out the modal matrix and also find the spectral matrix. Spectral matrix means your D only, and then evaluate A to the power 5, right? So now I will be finding out A to the power 5. So what I'll suggest you, all of you pause the video and try to do it yourself and then check whether you are doing it correct or not. Okay, so let us start. Now first thing, I need to write down the characteristic equation. Characteristic equation means lambda square minus p1 lambda plus p2 is equal to 0. Implies lambda square minus p1 means 3 plus 1, that is the sum of diagonal elements. So 4 lambda plus p2, p2 means determinant value. Determinant value means 1 into 3 is 3, 3 minus 8. So it will become 3 minus 8 means 5. 3 minus 8 means minus 5 is equal to 0. Correct? So my characteristic equation is lambda square minus 4 lambda minus 5 is equal to 0. So use your calculator, go to mode, go to equation and solve this. So you will get your eigenvalues are minus 1 comma 5. Correct? Now for eigenvector, we will write the question again as 1 minus lambda 4 2 3 minus lambda xy is equal to 0 0. Correct? Now we will do one by one for both the values. So first let me do for lambda is equal to minus 1. So when I am doing for lambda is equal to minus 1, 1 minus of minus 1 will become 2, 4, 2, 3 minus of minus 1 is 4. See, again both the rows are same. So xy is equal to 0 0. Implies 2x plus 4y is equal to 0. So 2x is equal to minus 4y. So divide both the side by minus 4. So it will become x by minus 2 is equal to y by 1. So what will be your eigenvector? Eigenvector will be equal to minus 2 and 1. Correct? So I got my first eigenvector. Now let me work for the second eigenvector, which is corresponding to lambda is equal to 5. So now let us work for lambda is equal to 5. See, I have written minus 2, 1. Even if you write it as 2 minus 1, it is correct, because every multiple of this is a eigenvector only. So for one eigenvalue, I can write infinite eigenvectors, but all are multiple of each other. So now let's work for lambda is equal to 5. So substitute now. So 1 minus 5 is minus 4, 4, 2, 3 minus 5 is minus 2, xy is equal to 0, 0. So I'll have minus 4x plus 4y is equal to 0. Means 4x is equal to 4y. So what is the eigenvector? Second eigenvector is 1, 1. Because I can divide both the side by 4 and x by 1 is equal to y by 1 I'll get. So now what is the modal matrix P? Modal matrix P is equal to minus 2, 1, 1, 1. Correct? Now I will find out P inverse. So again I'll go to mode. See, every time when I am teaching you, I am also doing along with you, so that you will understand. You should also do along with me. Okay, don't wait for the answer to appear. You should do yourself. So 1 is equal to 1 is equal to 1 is equal to this. Now on shift 4. Now I did mat A and inverse x to the power minus 1 I'll press. So I get the answer. So my first value is minus 1 by 3. I'll go to the second value, that is 1 by 3. Then I'll go to the third value, 2 by 3, fourth value. Then I'll go to the last value, that is 1 by 3. So this is my P inverse. Now once you get P inverse, what is the next thing you have to do? You have to find out D, that is spectral matrix or the diagonal matrix, which is equal to P inverse AP. Right? So I'll substitute the value. P inverse is, you can write 1 by 3 outside and minus 1, 1, 1, 2. Correct? So this is also a way to write it become little easy, because you don't have to put the fraction into it. Right? So you will not be putting the fractions, or easily you will get the answer. So see, I have multiplied and I have checked. So I got my D is equal to 1 by 3 and this. So 1 by 3 when I take inside, minus 1, 0, 0, 5. Okay, and you can see that my eigenvalues are coming in diagonal. Now what is the next part of the question? I need to find out a to the power 5. Correct? Now when I am finding out a to the power 5, what you have to do now? A to the power 5 means you have to apply the formula P d to the power 5 P inverse. Correct? So now P is what? P is minus 2, 1, 1, 1. D to the power 5 means minus 1 to the power 5 is minus 1, 0, 0. And then you have to find out 5 to the power 5. Right? So I'll do 5 to the power 5. Which is 3125. Okay, and P inverse is what? P inverse we have already written here. Minus 1, 1, 1, 2 and 1 by 3 is there, which I can write it here. Correct? So now if you multiply this, you will get 1041. Then you will get next is 2084. Then 1042 and 20, this is 83. Right? So this is how you have to do the questions. Questions are very easy. Only you have to be very careful in numbers. And while using the calculator, you have to be very particular that you should not do any silly mistake. Now let's do this question. I need to diagonalize this matrix. So my step 1 is characteristic equation. What is characteristic equation? Characteristic equation is lambda square minus P1 lambda plus P2 is equal to 0. In this question, P1 is equal to minus 19 plus 16, which is equal to minus 3. Okay. And P2 is equal to minus 19 into 16 plus 7 into 42. That is the determinant of this matrix. So even if you want, you can use the calculator directly. Go to the matrix, pick up any one matrix, and then select the order. That is 2 cross 2 matrix, and my matrix is minus 19 is equal to 7 is equal to minus 42 is equal to 16. So I got this matrix. Now I want to find out determinant. So do on, shift and 4. So now they are asking what you want. So 7th number says determinant of 7. Determinant of what? Mat A. So shift 4 you do. So all will come. So pick up mat A, that is number 3. Close the bracket and then you find out the answer. Answer is coming to be minus 10. So P2 is minus 10. So what is my characteristic equation? See, in exam when you write characteristic equation, you get some marks. Then value, again some marks. In maths always there is a step marking. Okay. So this become plus 3 lambda minus 10 is equal to 0. Right? This is my characteristic equation. Now use your calculator, solve this equation. So you will get the roots of this equation. So lambda is equal to 2 and minus 5, which are the eigen values. Now how to check whether my eigenvalue is correct or not? Just add these two values. You are getting minus 3, which is equal to sum of diagonal elements. So this is a check. How you can check. Now let me find out the eigenvector. So for eigenvector, first you write the standard minus 19 minus lambda, 7 minus 42, 16 minus lambda. Okay. So x, y, 0, 0. Correct? Now let me work for lambda is equal to 2 first. If I put lambda is equal to 2, minus 19 minus 2 is minus 21, 7 minus 42, 16 minus 2 is 14. So xy is equal to 0, 0. Correct? So this will give you minus 21x plus 7y is equal to 0, implies 21x is equal to 7y. Divide both the side by 21. So x by 7. Divide both the side by 21. So you will get here 1 and here y by 3. Okay. So my eigenvector x1 corresponding to lambda is equal to 2 is 1, 3. Now go to the second one. Lambda is equal to minus 5. Substitute the values. So minus 19, here I am putting in this. So minus 19 minus of minus 5. So basically plus 5. So it will be minus 14. Correct? 7. Then minus 42. Now 16 minus of minus 5 means 21. Correct? Then x comma y is equal to 0, 0. Right? So now see, here also it is same. 7 3s are 21 and 14 3s are, if I do, so 3 1s are 3 and 42. Correct? So it's correct now. Now 14x plus 7y is equal to 0 means 14x is equal to 7y. Divide both the side by 14. So x is equal to y by 2. So what is the eigenvector? Second eigenvector is 1, 2. Right? So what is my modal matrix? Modal matrix is 1, 3, 1, 2. Correct? So now I have got my modal matrix and now my next job is to find out P inverse. Correct? So my modal matrix I got very easily. Now let's work for P inverse. So again I will suggest you, don't do it manually. Take your calculator. Okay? Take your calculator and find out P inverse. So now P inverse is equal to minus 2, 1, 3, minus 1. You use calculator and check whether you are getting the same value or not. Okay. Then next step is what? I need to diagonalize. So diagonalize means P inverse AP I should do. So P, and I know what should be the answer. What should be the answer? Answer should be like this. My first eigenvalue is what? Go back and check what is 2. Right. So 2, 0, 0, minus 5. It is always be like this. And if on multiplying you are not getting this, means you have done something wrong in P or P inverse. Okay. So this will be minus 2, 3, 1 minus 1, minus 19, minus 42, 7, 16, and 1, 3, 1, 2. So this is how I can find out the diagonal matrix, right? So now let's do the next question. Now you have to diagonalize this matrix 4, 1, 3, 2. So again, let us write down characteristic equation. What will be the characteristic equation? Lambda square minus P1 lambda plus P2 is equal to 0. So lambda square minus P1 means 6 lambda plus P2 means 4 to the 8. 8 minus 3 is 5. Correct? So this is my characteristic equation. Now I should I should use my calculator and get the value of this, right? So, or you can do it manually. I will suggest you not to do manually. Use your calculator always. So lambda square minus 6 lambda. So sorry, I'll just split the middle term. Lambda square minus 3 lambda minus 2 lambda. See, now here I should write 5 lambda and 1 lambda. So minus 5 lambda minus lambda plus 5. So lambda common, lambda minus 5 minus 1, lambda minus 5. So lambda is equal to 1 and 5. So lambda is equal to 1 and 5. Now if I want to check whether these two are correct or not, what I should do? Add them. 5 plus 1 is 6. Now check. 4 plus 2 is 6, means I am correct. So this is how after getting the eigenvalue you should do a check whether your values are correct or not. Otherwise everything will go wrong. Now I will go for the vectors. For vectors, first I write down the equation 4 minus lambda 1 3 2 minus lambda x y is equal to 0 0. Correct? Now let's do one by one. First, for lambda is equal to 1 I am doing. So for lambda is equal to 1 when I am doing, so 4 minus 1 is 3, 1, 3, 2 minus 1 is 1. Xy is equal to 0 0. Correct? So this give me 3x plus y is equal to 0, implies 3x minus is equal to minus y. Correct? Divide both the side by minus 3. So x upon minus 1 is equal to y upon 3. So my first eigenvector x1 is equal to minus 1, 3. Correct? Now go for lambda is equal to 5. So when I go for lambda is equal to 5, 4 minus 5 is minus 1, 1, 3, 2 minus 5 is minus 3, xy is equal to 0, 0. So minus x plus y is equal to 0 implies x is equal to y. So my eigenvector x2 is equal to 1, 1. So what is my modal matrix? P is equal to minus 1, 3, 1, 1. Okay, if suppose you write first column is 1, 1 and second one that, no problem. At the end your answer eigenvalues position will be swapped, nothing else. Now do P inverse. So let's go to the calculator again, go to matrix, select matrix 1, select the order 2 cross 2. Now minus 1 is equal to 1 is equal to 3 is equal to 1 is equal to, on shift 4 pick up mat A and press the button inverse. So you will get minus 1 by 4, 1 by 4, then next value is 3 by 4 and 1 by 4. You can also write it as 1 by 4 outside, minus 1, 1, 3, 1. Correct? Now your D is equal to P inverse AP. So if I put the value 1 by 4, minus 1, 1, 3, 1. A is your question. So go back 4, 3, 1, 2. P inverse AP. What is P? Minus 1, 3, 1, 1. So when you multiply this, you will get both your eigenvalues in diagonal, that is 1 and 5, 0, 0. Right? So this is how I can say this is a diagonal matrix for the given matrix. Okay. Same way now you have this question. Now let us work for this one. So again, first characteristic equation. So characteristic equation means lambda square minus P1. P1 means 2 plus 2, 4. 4 lambda. Okay, then plus determinant value, 2 2s are 4, 4 minus 1 is 3 is equal to 0. Okay, so 2 factors of 3 whose sum is 4. So lambda square minus 3 lambda minus lambda plus 3, take lambda common. So lambda minus 3 minus 1 lambda minus 3. So lambda is equal to 1 and 3. Now let me find out the eigenvectors. So for eigenvectors you need to write first this. Correct? Now here xy is equal to 0 0. Now let me do one by one for both the values. For lambda is equal to 1, when I am doing, what I am getting? 1 minus 1 minus 1 1. X and y. Correct? So this is equal to 0 0. So I have x minus y is equal to 0 implies x is equal to y, means capital X1 is equal to 1 1. First eigenvector I got. So now let's go to the second eigenvector. So second eigenvector when I am doing, so 2 minus lambda. So 2 minus, my second eigenvalue is 3. So 2 minus 3 is minus 1, minus 1, minus 1. 2 minus 3 is again minus 1. Xy is equal to 0 0. Right? So minus x minus y is equal to 0 implies minus x is equal to y. So my eigenvector corresponding to this is equal to minus 1 1. Even if you write 1 minus 1, that is also correct. So what is your modal matrix P? Modal matrix P is now 1 1 minus 1 1. So I will find out P inverse now. So again same process, go to mode, go to matrix. Okay, pick up mat A, it's order 2 cross 2. So 1 is equal to minus 1 is equal to 1 is equal to 1 is equal to, on shift 4, mat A you pick up and press the inverse button. So I got my value as 1 by 2, 1 by 2, minus 1 by 2 and 1 by 2. Correct? Now D is equal to P inverse. P inverse is what? I'll write the formula first. P inverse AP. Then P inverse is 1 by 2. 1 1 minus 1 1. P inverse A. A means your question. So 2 minus 1 minus 1 2 and P. P means 1 1 minus 1 1. So when you multiply these three, you will get your 1 and 3 here. That is both the eigenvalues, and 0 0 here. So this is the diagonal matrix for the given question, right? So same way you can do this one. I think this we have just done 4 2 3 1. No, only the numbers are here and there. Remaining it is same only, right? So I'm not going to do this because it is exactly same. So all of you can try this question now, right? Same way this question also you can try. Same way. Now here you have to check whether it is diagonalizable or not. So let us do this one. What will be the characteristic equation? Lambda square minus P1. P1 means 2 plus 1, 3 lambda. Okay. Then plus P2. P2 means determinant value, that is 2, is equal to 0. Now lambda square, 2 factors of 2 whose sum is 3. So minus 2 lambda minus lambda plus 2. So lambda if you take common, lambda minus 2 minus 1 lambda minus 2. So lambda is equal to 1 and 2. So now I will find out the eigenvector. So 1 0 1 2 minus lambda minus lambda. X y is equal to 0 0. Correct? So now I'll do first for lambda is equal to 1. So when you do for lambda is equal to 1 0 1 0 and 2 minus 1 is 1. Xy is equal to 0 0. Right? So 0x plus y is equal to 0. So 0x is equal to minus y. Right? So this will become x by 0 and y by minus 1. See students, here we did a small mistake. 0x is equal to y. This is the equation. We need to figure out the values, right? So in place of a coefficient of x is 0. So y I have to take some non-zero value. So I will take it 1. Okay. So I took it as 1 and then I got P inverse, right? So now even if you take minus 1, it's correct because every multiple is also eigenvector. Now D is equal to P inverse AP. So substitute the value of P inverse AP. So you should get 1, 2, 0, 0. So this should be your diagonal matrix. So I hope now you understood the concepts and do more and more questions because it required only practice. Concept is same everywhere. It requires just practice. So if you like it, like the video, share the video and subscribe the channel so that once I'll upload the video, you will get a notification. So I will try my level best to upload all the remaining topics which you can study for your exams and do well in the exams. Thank you.